Okay, so in this video we're going to focus our attention on bearings, yeah, and they are very interesting. So if we understand this part, then us doing trigonometry is going to be simple for us, because it just has to do with finding angles, and if you know how to find angles, then trig won't really be something that will really trouble us. Okay, so we're going to use this format to understand how we find angles and which angles we are looking for. Okay, so now let's say we have these two lines as parallel lines, and we know to say, according to mathematics, we know to say parallel lines are just lines that are not going to meet. They can go as far as possible, either on this side, okay, or on this side. The thing is that they are not going to meet at any point. Okay, so now let's say we are going to use these arrows like that, okay, to show that they are parallel lines. And let's say we introduce a line which is called the transversal. And you're talking about the transversal line, I'm not necessarily talking about a line that is okay, would say perpendicular like that, meaning it's at a 90 degrees angle with this part or that part and that part there and that part, like that. That is not what we are necessarily talking about. But in this case, of course, this can also work, but that's not what we are interested in at this time. We are talking about a line that is slant, meaning it's a bit bent like that, or you can put it like that. It's up to us. Okay, so that is what we are going to do. That's what we are going to use. Okay, so you put it like that. So that line, as I said, is called the what? It's called the transversal. And we are going to, this line is going to, this format is going to help us understand which angle is equal to which one, and so on and so forth. Yeah, so now in this case, we have, if you have observed, we have on each side, they are more like the same, but we have an angle here, okay, we have an angle there, we have an angle here, we have an angle there, we have an angle here, and we have an angle here. All the same, this side we have an angle here, and we have an angle there, we have an angle there, and we have an angle there. Alright, so now here's what we need to keep in mind. I'm going to name these angles using letters. I'm going to say this is my what? My A, okay, say this is B, C, D, E, F, G, and what? And H. So here is a thing we need to note, we need to keep in mind to say, I want to show you the angles that are equal to each other. So angle A is equals to what? Is equals to angle what? Angle D. Same, angle C is equals to what? Angle B. These are opposite angles. Okay, then when it comes to what we have on the second line, which is, I would call this one, it's all the same as well. Angle E is equals to what? Angle H. Then angle F is equals to what? Angle G. Okay, so now we also need to keep in mind to say angle E is also equals to what? Angle D. They make what I would call something like a Z, like that. So we know to say okay, so when it comes to, like, we have two forms of Z's here. We have one that is a bit stretched. There's this one here, okay, and there's another one that is what? That is stretched in that manner. And if you have observed, this is our E, and this is our what? This is our D. So hence we can also derive another understanding by us saying what? Angle C is equals to what? Angle F, meaning we have our C here and we have our what? We have our F here, like that. So these are equal. Saying angle E and D are what? Are equal. Then C and F are what? Are also equal. So whenever you just see something like a Z, whatever, in whatever form, it can be like that, It can be like this. It can be rather like this. We know to say this angle and this angle are what? Are equal. Okay, so that is the illustration that we are looking for there. Okay, then which other one can also help us? We are also going to say angle F. Okay, so we are going to say F plus what? Plus D is equals to what? 180. Okay, so meaning even C plus what? Plus E is also equals to what? 180 degrees. So and we know to say comprehensively, if we are to talk about the first line, meaning we can say A plus what? B plus what? C plus what? D is going to give us what? 300 and what? 360. So let's say we are not given B and we're given A, C and D, then it's going to be very easy for us to find what? To find B, because we know to say adding the summation of all these angles is going to give us what? 360 degrees. Okay, so when it comes to bearing questions, okay, when it comes to questions on bearings, let's say we are given something like okay, let's say we are given something like this. So you find that bearings can be as complicated as possible sometimes, but if you understand how they are coming up with those with those angles, how the angles are given, then everything is going to be simple for you. Okay, so let's say this is our what? This is our north, and this is our, this is also what? Say that is our north. Okay, so let's say we have our angle here. Let's say here we have what? We have O, and here let's say we have A. Here we have what? Here we have B. Okay, so now let's say a question is asking to say find the bearing of, say, I'll just write the bearing. Okay, the bearing of, I'll say first is what? I'll say A from what? From O. Okay, so we are going to use this one as our first example. So what does this mean? So now we are talking about your main area of attention is what? Is O, meaning you're looking for angles at what? At O. And what angles are those? They are those angles. It's an angle that connects O and what? O and A. Okay, and in this case what you should keep in mind is that if you don't have a north, meaning a line such as this one, you can create your own. So you can, if you look at O, we don't have a line there. So in this case I'm not using angles that are given, I'm just showing where and what it means by bearing of that from whatever you're given. So you say this is our north of what? North of O. So when you're talking about the bearing of A from O, meaning you're looking for a line that connects A and what? And O, and this is the line here, this line. So now how do you find that angle? So you start reading from the what? From the north. That's why it's very important for us to have what? The north. So you start reading from the north, meaning you can start from this point above. We can start, this is our O here, meaning start from above O, you go like that in a clockwise movement, meaning you end there, then that's your angle there. So that is your bearing of what? Of A from O, meaning let's say here you had a 30 degrees. How do we get this angle? So we know to say, if we were to look at AO, it's interesting because what we have here is more like we have this, we have that. Okay, so it's more like here we have what? We have A, and here we have what? Here we have O. So when you look at these two angles, here and here, these we know to say they add up what? 180. From the what? From the previous example that we're given here, we know to say C and F, this part. Sorry, C and E rather. C and E are equals to what? 180, or F and D are what? Are equal to what? 180. So it's just a matter of you ignoring whatever you can ignore to get whatever you want to get. So meaning if you add this angle here and this angle, you must get what? 180. So if you find this angle, you can subtract this angle from what? 360, because we know to say this is to make a complete revolution, you have what? 360. So you can say 180 minus 30, this is going to be what? 150 degrees. So now, for you to find whatever is remaining, meaning this 150 degrees is part of what? Is part of 360. So you can say 360 minus what? 360 remove 150. That would be what? 210. So the bearing of A from O is what? 200 and what? 210. So that's how you would get to approach that question. So now, what if we were given okay, so now what if the question says find the bearing of what? The bearing of, okay, let me say A from what? From B. And again, always the number that comes, the letter that comes at last is what you are focusing on. So in this case, this is our O here. I mean, this is our B. We already have our what? Our B, and already have what? A north. So everything has been made simple for us. So we are looking for the angle that connects what? A and B, and that angle, we need to, when you read that angle, it should give you what? When you're reading that angle, you should reach a point where you reach that line that connects A and B, and that is what? This line right here. So what you are looking for is what? Is the angle from this point, the angle from this point through to that point right there. So we know to say, when you look at starting from this point, I'll try to put it in yellow, starting from this point to come to that point, it's very easy to find because those are angles on a straight line, and we know to say angles on a straight line are equals to what? 180 degrees. Someone might want to ask to say, how is it 180 degrees? It's very simple. If you have this, if you have that right there, this is a line, okay? So we know to say here we have what? A 90 degrees angle, and here we have what? A 90 degrees angle. So when you add these two, you're going to get what? 180 degrees. So if you add another 90 degrees, that's why you get what? 270. When you add another 90 degrees, that's when you end up getting what? The 360. So that's how those angles come about. Okay. So the only issue now can be us knowing how to find what? The angle that is where? The angle that is at this point. So how can we get to find the angle that is at this point? So there are times when we know to say, let's say we are given, if we are given an angle here, let's say we are given an angle here, okay, we're given an angle here. It can be very simple for us. If we are given an angle here, let's say this is angle what? Angle X. Okay, so how can this angle which is X help us? So now, as I earlier said, when it comes to bearings, it just requires you to do what? To think more, and please try as your level best to ignore what you don't want to use. Of course, they might seem like there are a lot of things, but try to ignore some things so that at least you get to use whatever you have to get what you want. So remember to say, here we have an A, here we have what? B, here we have, this is a north, and that is what? A north. This angle is already these two are already making a C, meaning this angle and this angle are what? Add up to 180 degrees. So we know to say at point A, that's where I have what? 30 degrees as well as what? As well as X. Okay, so meaning when you add these two, we can subtract from 180 to get what? What is here, which is, in this case, is this part. So when we get this part as well, how does it help us to get what is remaining? Of course, you might want to ignore the 180 at that point because we already know what is here. So what do? We can subtract whatever we get here. So meaning we can say the bearing of A from B is equals to what? I would say 360 degrees minus what? Open bracket, I'll say 30 plus what? Or rather, I would say 180 minus what? 30 plus what? Plus X. So when you add these two, you subtract them from 180, then again what you get subtracted from 180, then that would be what? That would be your answer. So it's just a matter of using whatever that it is that you are given to get whatever it is that you want. And you should always keep in mind there are those times when they give you hints. It's not always that they're going to give you angles. So they might give you maybe an angle of this manner. Okay. Okay. Let's say you have a triangle of this manner. And they would include anything that they would want to include. Yeah. So you find that maybe they would do this. Then they give you an angle here. Let's say they give you what? 32 degrees. Then maybe there's a point where, let's say this is our A, this is our what? B, this is our what? Our C. Then there's a point that whereby you have reached a point where your calculation needs you to have your what? Your A. What do? We look at these two. It basically means this angle C and angle A are what? Are equal. That is what it means. But if we were to do this, instead of us putting 2, we put what? 3. It basically means this angle and this angle and this angle are what? Are equal. And we know to say a triangle is add up to what? 180 degrees. So meaning to find these, we can say this is your x, this is your x, this is your x. So meaning you're saying x plus x should give you what? 180. This is 3x is going to give you what? 180. You can divide both sides by 3. So there we are going to, when you divide 3 into 18, you're going to get 6. So meaning x is equals to what? 60 degrees. So meaning you have a 60 degrees here, you have a 60 degrees here, you have a 60 degrees here. Okay, when you multiply those two by 3, you're going to get what? You're going to get 180 degrees. So as I said, it's not always when they're going to give you angles. They'll just give you a hint or a sign, and sometimes they would not really maybe put these, but they would use words. And if they say an isosceles triangle, you know to say it's just an angle where two sides are equal, meaning this part, and they'll do this. It's more like written in that manner. Okay, quadrilateral triangle, these all the three are what? Are available. So it's not always, again, when you're given these signs. Sometimes they use what? They use words. Yeah. So that's how you get to answer such questions. And if you know how to go about answering this question, if you know how to handle angles, looking at this diagram, if you follow this diagram properly, then it's going to help you answer any question that you can face on bearings, and of course as we head towards trigonometry. Yeah. So that's all from this video. Thank you.